Hello and welcome to the HyDeploy webinar, Unlocking Deployment of Hydrogen in the Grid. So my name is Andy Lewis and I work in Cadent's Future Network team. I've been working on the HyDeploy programme since it started over 4 years ago. I formulated the project consortium and I've been responsible for delivery at Kiel ever since. Okay, so today's webinar will last 1 hour and will consist of a short video to begin with, followed by roughly 30 minutes of presentations, and then the remaining time will be spent with a Q&A session. The presentations will be given by Chris from Progressive Energy and also Zoe from Kiel University. During the Q&A sessions, you should be able to put questions via the chat function. So please feel free to submit the questions and then we'll pick them up at the end. The panel for the Q&A session will be members of the HyDeploy consortium, and I'll introduce them individually at the start of the Q&A session. Okay, so now we're going to start with a video.
In the UK, we have committed to reducing CO2 emissions by 100% by 2050. It's a massive challenge, and now more than ever, we need innovation to drive change. Hydrogen is an absolutely vital part of the plan. In the heart of the Midlands, a pioneering energy demonstration is underway.
So when hydrogen is burnt, it doesn't produce any carbon dioxide, which is emitted into the atmosphere, but it still produces heat and energy. 1/3 of the UK's carbon emissions is from heat, and that, to this date, has been hard to decarbonise. We're going to use hydrogen in the gas network. What we're trying to do at Kiel is put 20% by volume of hydrogen into the network.
Essentially, the evidence base has now been developed and assessed by HSE to conclude that it should be no less safe when blending hydrogen with natural gas than it is where we distribute natural gas today.
23 million customers in the UK are already connected to the world gas network that we have in the UK. From an infrastructure perspective, it makes a lot of sense to decarbonise the gas which is within the network already.
If a hydrogen blend is distributed across the whole of the UK, that's the equivalent of saving 6 million tonnes worth of carbon, which is proportionate to taking 2.5 million cars off the road.
When we look at net zero, there's going to be a number of options open to us, from electricity to pure renewables and green gas. So all have got a part to play.
This isn't a competition between electricity and gas. The CCC report was absolutely clear. In order to hit our 2050 ambition, we need to move on all fronts, and we need to move now.
It doesn't matter how good the technology is, because in the end it will sink or swim with the public acceptability of it. And the majority of the participants in our study have actually been really proud to be part of the project.
Well, sustainability is a key overarching strategic aim for Kiel. Try and embed it in all our activities, in our research, our education, across the campus, the community, and in our external and business engagement. Aiming to be just genuine sector leader in low carbon sustainability. And HyDeploy aligns incredibly well to all of that.
If you want to hit the government 2050 targets of carbon neutrality or carbon neutral, you have to start utilising renewables, and especially hydrogen, in line with a renewable energy source to create that. So wind power, tidal power, that stuff that then creates the electricity that creates the hydrogen. It's the only way to meet those targets.
During this particular project, I've been responsible for a number of enabling works on the network to make sure that it's fit for purpose for the project itself. The installation of a gas chromatograph, gas sampling points, the installation of 8 test boilers that's going to be running during the project itself. I've assisted with the compound, and probably more importantly as well, working with the HSL on getting an exemption on the gas safety case to enable us to provide a network that hydrogen can be incorporated in.
The purpose of the HyDeploy project is to demonstrate that we can utilise and transport hydrogen blends safely in a live gas distribution network. What we've got here is the compound, and the purpose of the compound is to firstly produce the hydrogen, and then secondly to inject it into the Kiel network. Firstly, what we do is we produce the hydrogen via the electrolyser, and in the electrolyser we have water, so H2O, and also electrical current. The electrical current will split the water into hydrogen and then oxygen. The oxygen is vented into the atmosphere, and the hydrogen is then transported into the buffer tank where it is stored, and then from the buffer tank it goes into the grid entry unit here. And in the grid entry unit, the hydrogen is mixed with the natural gas and then injected into the gas network, and then once it's in the gas network it goes to a governor, so a pressure reduction site, and then into the wider Kiel network. This behind me is a gas chromatograph. We've positioned this at the extremity of the network. Its purpose is to measure gas composition. So by having it at the extremity, we can make sure that there's still hydrogen within the network at the correct volume.
We also have the support from the boiler manufacturers. We have Worcester Bosch, we have Valent, we have Ideal and Baxi. And they've provided for us between them 8 boilers. One of those boilers from each manufacturer is operating on natural gas and one is operating on the blend. We are running those boilers very hard to represent a long life operation of those boilers. This allows us to make important tests and checks on those boilers as they're operating.
I feel really excited about taking part in the HyDeploy demonstration. It's a really good project to be part of, and it's especially good to be able to support it in the comfort of your own home. I've not noticed any difference using the blend in my home. For cooking and for heating, it all is absolutely normal, and you'd even barely notice it was there.
The next stage is to scale this up. It's about doing it at a small scale, making sure we've got all of the wrinkles ironed out, and then we're going to start deploying it into the communities in a year's time, and that's hugely exciting.
The main benefits of HyDeploy North East after the project at Kiel is that we are repurposing the equipment. We're reusing the hydrogen production equipment, the hydrogen grid entry unit, and we're taking what we've learned and repurposing that for the trial in the North East.
And because HyDeploy is an innovation project, it's fairly new territory. So the learning that we've taken from Kiel with regards to our customers and what it is that they want from us in a project team will be crucial when we go into the next phase and next demonstration project. What we need to do is address the evidence gap that we have following Kiel and then following the North East trial, and then we can cover that in the North West.
By the end of that 6-year period, we're looking to be at a position where we can then roll blending out across the UK.
It is a pragmatic step to the transition to a hydrogen-based economy. So hydrogen as a concept is quite revolutionary, so it's that thing off in the distance, but HyDeploy is translating that into an evolutionary, pragmatic change within the gas industry that's digestible and deliverable.
My message to the new government is actually the time is now. We are now demonstrating that we can dramatically reduce the carbon intensity of our heating system with no impact on customers at all. We're coming together as an industry to solve a national challenge. We need a clear policy and a clear direction to enable us to travel at pace.
Okay, great. So I'm hoping you all saw the video. If you didn't, the video will be available at www.hydeploy.co.uk, which is our project website. So now I'm going to hand over to Chris, who's going to give you an overview of the HyDeploy program. So over to you, Chris.
Fantastic. Thank you, Andy. And what a pleasure it is to be here on this webinar today. If we could move on to that first slide, that would be very helpful. Thank you, Peter. So yeah, my name is Chris Manton-Whitten. I'm one of the directors at Progressive Energy, and it's been my pleasure to be part of the HyDeploy program since its inception, along with Andy and the team from Cadent as we built the team together to deliver HyDeploy. So could we have the next slide? Thank you. That's great. So as we all know, heat forms a very significant part of our energy mix here in the UK. And it is quite challenging for us to address that. Now, the Committee on Climate Change has identified that hydrogen is a necessity as part of our journey to net zero. And not only that, but they see that grid blending is an important part of that journey too. And what is it about grid blending that is so helpful? First of all, there is no change for customers. So we're rolling out hydrogen, allowing customers to get used to hydrogen being part of their energy mix, just as normal day to day. It allows us to build up the hydrogen supply chain, both in terms of the production of hydrogen, but also the operations out on the network and the supply chain to supply equipment out as well. As Andy has said on the video, it offers the opportunity to save around 6 million tonnes of CO2 across the network, which is around equivalent of 2.5 million cars off the road. And it provides a deliverable roadmap for deeper savings. So if we could have the next slide, Peter, that would be great. So the objective of HyDeploy is to enable bulk deployment of hydrogen blending in the UK gas network by demonstrating its safe transportation and use. So today we have biomethane being injected widely into the gas network, and we're looking to have the same kind of situation with hydrogen. It's been configured as a series of public demonstration projects. The first one is on the private Kiel network. For the reasons that Kiel run their own network, we have a controlled number of households. We have around 100 households and 30 commercial type buildings, whether it be lecture theatres or whether it be offices and refectories. Good site for us to do that initial demonstration, which we then roll into the public trials as was indicated in the video, and we'll pick that up at the end of this presentation. If we could have the next slide, Peter, that'd be great. A key part of the whole programme has been to establish the safety case for us to be able to do that. So in the UK, the quality in our gas grid is controlled by the gas safety management regulations, and those stipulate that we can only stay below 0.1% volume in the gas grid. So therefore we needed to have an exemption, and again, an exemption is a process which has been done before. It's how we allow aspects of our biomethane quality to be injected onto the network. So we needed an exemption to that. In order to secure that exemption, we need to demonstrate that persons affected by that exemption won't be prejudiced by it. So we needed the evidence to demonstrate that 20% volume hydrogen is as safe as natural gas. And we did that by building a quantitative risk assessment backed by rigorous evidence. Using that evidence, we modelled the UK network. We then translated that into what the Kiel University gas network looks like prior to the trial, and then what it looked like during the trial. And through that evidence base, that very comprehensive evidence base, we demonstrated and secured that first hydrogen exemption in November 2018. If we could have the next slide, that would be great. So a real important part of this has been our customer focus, and Zoe will tell us a little bit more about that later. But we needed to ensure that the customers understood and were on the journey with us to blending. And we also needed to be able to undertake some important safety tests in people's homes, checking the quality of their installation on natural gas and the quality of their appliances operating on natural gas. We even tested that using bottled gases at Kiel to ensure that we had a good solid evidence base moving forward. And again, it gave us that all important opportunity to engage with our customers and consumers at Kiel University. So following the exemption, if we can have the next slide, we then proceeded to the installation. And here are just a few photographs of that installation process starting November 2018 and finishing in October last year. You can see on the top left the initial foundations, and then the next photograph is showing the factory acceptance testing of the electrolyzer. And the next one is when we were testing the grid entry unit, which we did on NGN's Low Thornley site, which provided us an ideal place for us to test that prior to moving it to Kiel. And then you can see a series of photos as we moved and installed the equipment at Kiel, including some of the equipment out on the network, which we'll talk about a little bit later. And then finally, you can see the full installation that we completed in October 2019. So in just under a year, we achieved that full construction. Yes, here we go. Here is a photograph of the an aerial view of the compound. If we go around clockwise, you have the transformers bringing in the power to the power supply unit, which is then connected to the electrolyzer using renewable electricity. That is then produces the hydrogen. As we indicated in the video, that goes into a small buffer tank so that we can manage the supply and demand of that hydrogen, which is then drawn in by the grid entry unit. The grid entry unit takes natural gas from the network and blends in the hydrogen. And you can see we have this loop called the volume loop, which actually allows us to test and check that we've met our blending criteria before that gas is then released out onto the gas network at Kiel. Next slide, please. So, the end of October last year, we became the UK's first gas network to operate on a blend of greater than 0.1% volume hydrogen and natural gas. Obviously, in the past, we had operated on town gas, which included hydrogen, but this is a blend of hydrogen and natural gas. Now, in order for us to, in a carefully controlled process, increase the blend level, we had a series of checks. This gives you an idea of the kind of things we were doing out on the network. We needed to make sure the compound itself was operating as expected, that the governor was operating as expected. Measurements of gas composition across the network were as we injected at the front end. So we had a network measurement point permanently collecting data deep into the network, as well as taking laboratory tests. Gas, as we know, has a characteristic smell, which is really important in leak detection. We needed to make sure the rhinology, that leak detection smell, was still as we expected it to be. And we needed to make sure the network was all operating as normal. And finally, and importantly, we needed to make sure all the appliances out on the network are operating as required. So we went through that process. If we can have the next slide. I've just got a couple of examples of some of the data that we've been collecting. So here we have the gas chromatograph that, as I say, is deep into the network that's measuring. The top graph is actually showing the gas flow through the network. And as you can see, the instantaneous changes in gas flow are enormous. So you can see there are times where we've gone from, we've halved the gas flow in the network in just a matter of seconds. So that's the flow of gas in the network. And what you can see below is one example of the data set we were collecting from that gas chromatograph, which shows that we were managing to achieve an incredibly steady level, blend level, and the equipment was doing as we wished it to. Now, this has been more challenging than we expected. Nobody has ever tried to balance a blend into a network before. So we've made very good progress. We're looking forward to increasing that blend level further from the mid-teens that we're at as soon as the restrictions from C19 allow us to be blending again. But we've made very good progress. Again, we've had some challenges in the production of hydrogen, making sure that that is consistent too. But together, we have made huge progress, and we look forward to starting again once COVID-19 allows us to do so. If you can move to the next slide. And again, you saw in the video that we had the boilers that were hanging on the wall. Those are in addition to all the domestic boilers that we have in people's homes. These are boilers that allow us to take a much greater set of tests along with the manufacturers. And you can see here in one of the graphs here, we've just put this, which demonstrates actually when the blend was being turned off, we have a boiler temperature which is way up in the 600s, and you can actually see just a few degrees, but you can see the step change when the blend level changes. Now, we were able to collect data from that, which has allowed us to put technical bulletins out into the gas safe industry to show that actually their normal processes, the way they measure flue gas composition, can carry on just as normal when we're running with a blend as they are with natural gas. And this is the heart of the project, that business as usual can carry on whilst we're adding the blend in and we're reducing the carbon intensity. Could I have the next slide, Peter? So again, as you heard in the video, this is the first trial. We are then looking to roll out into a much greater number of properties. So our first trial in the northeast, which is being hosted by NGN, will go into over 600 properties in that area. We've already been and done gas safe checks there, and we are engaged with the community there. And in fact, the construction of that compound to deliver the hydrogen is already well underway, and we look forward to be blending into that network later on this year. And that's the first, followed by a subsequent trial, and then we roll into deployment. And what we've got here is two ways in which that deployment could happen. Two different scales. So on the left, you have HyNet Northwest. This is bulk hydrogen production using carbon capture and storage, which is allowing us to operate at orders of magnitude greater volumes than we're operating at Kiel. This will be delivering 3 terawatt hours of hydrogen from the first line that we've got there, and that will deliver to a variety of users, whether it is industrials, whether it is power generation, but also importantly as blending into that northwest region. And similarly, we've got an example on the right of the Integral program, which is looking at balancing the electricity and gas networks. This is a program by NGN, but again, this is looking at deploying electrolysis type technologies and blending on a more distributed basis across the network. Both of them are critical to rolling out hydrogen, both as a blend and in the longer term as deeper use of hydrogen and potentially conversion of the gas network to hydrogen. And that's what HyDeploy is offering us. It is that stepwise pathway that enables us to see hydrogen playing its role in helping the UK to meet its net zero targets in 2050. Thank you, Andy. I will now pass back over to you.